Welcome, everyone. If you're the kind of focused learner who just loves understanding exactly how our universe operates at the quantum level, well, you are in the perfect place. Today, we're looking into something truly mind-bending. We're talking about what is, quite literally, the world's most expensive car crash. But hey, we aren't talking about luxury vehicles colliding on a highway. No, we're talking about the ultimate scientific collision. In this explainer, we're going to unpack the incredibly fascinating mechanics of particle physics. We'll look specifically at massive facilities like the Large Hadron Collider to see exactly how pure destruction leads directly to profound discovery.
Okay, let's dive right into this. Why build giant machines just to break things? Honestly, it feels entirely counterintuitive at first glance, doesn't it? Usually, when humanity invests billions of dollars into highly complex pieces of technology, the entire goal is to keep them pristine, to keep them perfectly functioning. But in this specific realm of high-energy physics, the primary objective is literally catastrophic collision. Scientists are building the absolute most sophisticated, precision-engineered technology known to us just to smash fundamental particles apart. It's a fascinating paradox, and it's exactly what we're going to unravel today.
Section 1. The giant smashing machines. So, scientists construct these colossal engineering marvels. Massive rings of superconducting magnets buried deep underground, purely to smash particles together. Just think about the sheer scale of that effort for a second. We're talking about taking the tiniest building blocks of our reality, things like protons or lead ions, and basically turning them into a microscopic demolition derby. The monumental architecture required to deliberately isolate and shatter these subatomic structures is just staggering. It's the ultimate contrast, really, utilizing machines that literally span for miles just to manipulate particles that are vastly smaller than a single atom.
Let's move along and see how this builds in Section 2, Speed Nearing Absolute Light.
Now, what's really interesting here is the sheer contrast in velocity. Inside these machines, particles are accelerated to near light speed, which, ironically, is a heck of a lot faster than your Wi-Fi during final exams. We've all been there, right? Watching a loading bar absolutely crawl when we need it the most. But inside an accelerator, it's the exact opposite reality. We're pumping massive amounts of energy into these particles, pushing them to 99.9999% of the speed of light, the ultimate cosmic speed limit, right before the big event actually happens.
Section 3. Creating Cosmic Car Crashes.
And this whole process brilliantly illustrates the journey of modern particle physics. Step 1, we start by constructing this monumental, incredibly precise architecture. Then, Step 2, using massive electromagnetic fields, we achieve that near-light acceleration. This culminates in Step 3, the violent, calculated impact, the actual collision. And finally, out of that intense, concentrated energy, entirely new, heavy elements and elusive fundamental particles are born. It's a really fascinating progression that intentionally harnesses extreme destruction to drive profound creation.
See, when these relativistic particles collide, the resulting wreckage isn't just a bunch of random subatomic debris. No, it is pure, unfiltered discovery. Through this intense transfer of energy, physicists can actually synthesize brand new elements that don't even exist naturally on Earth. But beyond that, breaking reality down at its most fundamental level allows us to observe incredibly elusive phenomena, things like the Higgs boson or the state of quark-gluon plasma, which is basically the primordial soup that existed mere moments after the Big Bang. The monumental effort, the extreme velocities, it is all completely worth it because looking under the hood of existence like this unlocks the deepest, most hidden secrets of our universe.
And that brings us to Section 4, Secrets of Controlled Chaos.
This whole phenomenon is the absolute ultimate expression of controlled chaos. We're deliberately crashing near-light-speed particles together to discover the deepest secrets of the universe. It's such a beautiful contradiction when you think about it. You've got these multi-billion-dollar supercooled magnets and hypersensitive detectors perfectly, meticulously calibrating the environment, all just to contain and monitor an inherently violent, chaotic subatomic collision. This deliberate disorder actually becomes our single most precise tool for scientific discovery. We aren't just breaking things randomly here, we're breaking things with absolute calculated intent.
So, the crucial point is beautifully captured by this idea. Basically, science loves controlled chaos. That's the overarching thesis of this entire physical endeavor. The action of engineering these massive structures, accelerating particles to the absolute limit, and orchestrating these microscopic impacts, well, it directly leads to the reaction of solving the universe's greatest mysteries. It's just a brilliant synergy between extreme, violent physical collisions and profound, elegant scientific truth. Which brings us to our final thought for today. If controlled chaos allows us to create new elements and observe the very building blocks of reality, what secrets will the next crash reveal? As these giant colliders inevitably get upgraded with even stronger magnets, and as particles are pushed to unprecedented energy levels, what new, fundamental truths of the universe are just waiting to be shattered into view? Keep that in mind the next time you hear about these massive scientific undertakings. Thank you so much for joining me for this explainer. Keep asking those big questions,